put them on one drawing to start, just to see where they are in relationship to each other. But then if you separate them so that you have separate drawing for each vector, because otherwise the main drawing gets so busy that it's just super complicated. All right. A charter boat leaves port on a heading of, what does this mean? No. When we have this notation in our book, it means off of north, go 60 toward the west. Okay. Now, that's not the angle we're going to want to use in a minute, right? Because it's for our components, we want off the positive x-axis. And it was 12 nautical miles. Okay. Then it says the captain changes course to a bearing of. So it really is happening out here at the end of this is the next vector. He changes course off of north 25 to the east. But we can do it as two separate vectors. It doesn't matter. And then he goes 15 nautical miles. And we're supposed to determine the direction and distance from port. This is actually one that it wouldn't be that hard to do with law of cosines. But I'm going to stick with the method we've been doing. Okay. The original path of the ship was 12 with a 60-degree angle here. So we want to break that into components. We're going to do 12 cosine of, what is the angle off the positive x? 60 plus 90, 150. Are we good? Everybody's okay with where we got that number? Okay. The second vector, I'm just going to go ahead and draw it on its own here. And it says it changes course to a bearing of off of north 25 to the east at 15 nautical miles. Okay. What do we want to use for that one? We want to use 15 cosine of, we need this angle, right? Which is my badly disproportional picture. But if this was 25 degrees and it's supposed to make 90, this is 65. Did I do that right? Okay, so component form is my friend because now I just get to add these together, right? I don't know, I have every color under the sun going on here. Okay, so we type 12 cosine of 150, make sure we're in degrees. That's going to be an issue on this quiz. I'm just warning you. 12 cosine of 150, close parenthesis, plus 15 cosine of 65, negative 4.05. Anybody? And same thing with sine. And I've tried just like not retyping it, but just redoing it and changing the cosines to sine, but I haven't found it any faster. I don't know about you guys. 19.59. Okay. So the distance and direction from port is the combination of those two vectors, which here, if we were to plot that vector where this ship is going to wind up, it would be over and up here somewhere. This is the resultant vector's components, okay? Now, if we went back to this original picture that I'm kind of having struggles with because I made it too small, if we put what happened when he wound up out here, does that seem like roughly the same vector? Okay. And to find the distance, that is a magnitude. Anytime I say the word magnitude in general, it means if you only have the components, you need to do Pythagorean theorem. So That will give us the magnitude or the distance in this case. Sometimes calculator is not my friend. What'd you get? Oh, I square rooted it twice. That's why I'm so confused. I got 20.0. Yes. Okay. What did you get? Okay. 20 nautical miles, right? Whatever that is. Okay. Then we need to find the angle direction from port to its current location. So I assume it left port. Yes. So we want how far back to, what's the angle back to the, here. Anyway, let's figure out an angle. How do we find any kind of angle, guys? Inverse tangent. If we do this question, okay, it's going to be the components is going to find us an angle, but it's going to find a weird angle. What's it going to give us when we do 19.59 divided by negative 4.05? It says negative 78.3 degrees. Are we in quadrant 4? We could add 180. Otherwise, this angle over here is 78.4. But if we add 180, it's an angle of 101.7 degrees. That's not really, that's off the positive x-axis, right? Both of these were off of north. Could we give them an angle off of north? How could we find this little angle in here off of north? Yeah, we could subtract 90 from this answer, or we could take 90 minus the 78.4. It's the same thing, I promise. $11.6, everybody? 11.7? 11.7? And that would be, I'm out of room. That would be 11.7 degrees what? Off of north towards the, off of north towards the, which is it? We were in quadrant 2, right? So it's towards the west. Oops, can't write with an eraser. Okay. I didn't think that question was that bad, but it's probably trickier than the one that's on the quiz even. So, all right, does someone have one more they want me to do before we work on the new stuff? We can come back to this. Is there one off worksheet 6? You said you were having trouble on worksheet 6. Worksheet 2, sorry. I knew what I meant. Worksheet 2. We didn't do 6 yesterday? I'm pretty sure I did 6 yesterday. Because this is the exact slides that were open yesterday. Okay, so this one is pulling 2,000 newtons above the positive x-axis. So we did 2,000 cosine 20, 2,000 sine 20. This one is pulling 20 degrees below at 1,500 newtons. So we did 1,500 cosine negative 20, 1,500. Someone, I hope, typed that correctly. Sine negative 20. Let's double check that real fast. 2,000 sine of 20, close parenthesis, plus 1,500 sine of negative 20. That's right. The 171 is still right. Then it wanted the resulting force, which is just the magnitude. So we did Pythagorean theorem. Okay? If we wanted the direction, guys, I didn't ask this, but if I did inverse tangent 171 over 3289, I get 3 degrees. Does that make any sense? I swear at the end of this class yesterday, I asked which way would the stump actually be pulled from this line. Because this is a stronger force, it would be pulled a little bit to the north, and it would be 3 degrees according to the inverse tangent. Okay, mostly the stump's going to go fly in this way, right? With all that force, but it is going to fly a little bit to the north of that line. Above, I don't know what you want to say. Okay, one more question though off this. What? 8? Okay, person in a canoe wants to cross a 65-foot wide river. He begins to paddle straight across. Can my river go this way for you guys? 65 feet here. Begins to paddle straight across at 1.2 meters per second. Well, a current is flowing perpendicular to the canoe, so the current is flowing this way at 3.2 meters per second. What is the speed of the... What? Oh! Read the question carefully, Hofbauer. We don't know this. We know the resulting speed of the canoe is 3.2 meters per second. Aha, no wonder it's confusing. It's really not hard. Do we need to know that it's 65 feet wide? No. All right. One is going this way, one is going this way, and this is the resultant. All of these are the same label, so they're all magnitudes, they're all lengths. If this is 1.2 and we don't know this, and this is 3.2, we can just do Pythagorean theorem, because it said clearly they were perpendicular to each other. Did anybody get 3? It's 2.966, so 3 meters per second. One more? Yes? Which one? 9? Okay, pulling her luggage. Across the airport floor, she applies a 22 Newton force to the handle when the bag makes a 72, okay, so 22 here when it's 72 degree angle with the floor. What is the magnitude of force she must overcome to move the luggage straight forward? What effect would it have if she moved the handle closer to the floor, decreasing the angle? Okay. If she just wants it to go straight forward, she's overcoming what? I'm gonna find my key over there, the binder, will you? Well, let's do the components while we're thinking about this. 22 cosine of 72 and 22 sine of 72. Where did I put my calculator? Oh my mom's favorite saying growing up. There was a snake, it would have bit you. You heard that old lady saying? When you can't, when something's right in front of you. All right. Did you find it? All right, so this force is already moving it forward. This is the force that's being pushed at the up, okay? So this is really what she has to overcome if she wants to make it forward. So we're going to go with 20.9 newtons. But this leads to this question, and it should make sense, I hope. If she were to decrease this angle, that's going to make this force what? Less, right? Does that make sense? That if you were to take your suitcase and lean it down a little bit further, it would pull a little bit easier, right? Okay. So what effect would it have if she were to decrease the angle? It would be easier to pull, less force to overcome. I promise not to ask that question on a quiz, okay? I do hereby solemnly swear, okay? It's on video now, yes, okay. All right, we can come back to these if we have time, and we should have time again tomorrow to do some more vectors. So please, please, please do the homework so you can ask me questions. Right now we need to talk about polar coordinates. Okay? Brand new concept. Guaranteed. Haven't any of you done this, okay? Because we are going to graph on this. How many of you feel like you've maybe seen this graph paper before, ever? Kind of looks like a unit circle-ish, okay? But it has a variety of separate radiuses, radii, all these concentric circles they're called, right? Okay. I wish I had opened the section we're going to do tomorrow is all the really cool graphs you can make with this. So that'll give you something to look forward to. But today, we just want to talk about the basics of plotting points on this weirdness, okay? So to this point, we've only ever graphed using a rectangular system. But when air traffic controllers or people on a ship, that's the kind of thing that they see. Now, does it look a little bit familiar? Okay, they might see a plane here and a plane over here. It's yes, radar stuff, right? On a ship or a plane, or even just radar from ground radar to detect something. Is it in your games ever like that? Not like that? Okay. The polar coordinate system is used when we're using those, because what it does is it gives you an angle, okay, from what we call the pole, and it gives you a radius out, which is the distance, how far away it is. All right. Now, different systems might use a different pole. We're going to use the positive x-axis. Okay. In the polar system, we're going to call this, well, I said it wrong. It's the polar axis. The pole is considered just to be the origin. Okay. I'll be careful of my vocabulary from here on out. But we're going to start measuring off the positive x-axis. Do you see where that might tie into the vector stuff we've been doing a little bit? Okay. And the polar coordinates are going to be r and theta. When we put our calculator in polar mode tomorrow, it's going to say r equals instead of y equals, and it's going to say theta when we push that x button. Something to look forward to, okay? We get to learn a new mode. But for today, this is going to be the radius or the distance out, and this is the degree of rotation from the positive x-axis. Now, the issue is there are going to be multiple names for a single point. There's not one particular name anymore, okay? A positive value indicates a counterclockwise rotation, which is what we've always done, right? This is a positive rotation, that's counterclockwise. We good? All right. When r is positive, it lies on the terminal side. If r is negative, it lies on the opposite right. I'll explain that in a second. So at the top of your notes, it says the same thing pretty much. This graph paper is really detailed, the one I have up here. When we use this in class, it's not going to show these because it's too detailed to fit on our paper. You're going to have to know those in between, okay? It's probably only going to show pi over 6, pi over 3. You're going to be good with the fact that pi over 4 is in between there? Okay? And so on the way around. All right, so let's get to the fun. If Hofbauer were queen of the world, this would be reversed because you really have to rotate first before you can plot these, okay? In my mind, anyway. We're going to go around to pi over 4, and then we're going to go out 3 units from the pole or from the origin. That's it. So you find the pi over 4 line, and you go out. Now, this is the units, guys. This is a radius 1, because here's 0. If you went out an equal length again, this would be of a radius 2. Do you see what I'm talking about? This is the third one out, so this is a radius 3. There you go. Now we need to be really clear. This point we just plotted is 3, and this angle is pi over 4. It is not like 0, 3 or 3, 3. We could find its x and y coordinates with a little 3 cosine of pi over 4, 3 sine pi over 4. Okay? Tie into vectors. That's a lesson in a couple days, is going back and forth. Today all we get to do is plot. All right, the thing is, you can have positives and negatives and they mean something different. This is a rotating negative 120. We're all good with that? Rotating negative 120 would mean to go this way. This is in degrees. We have the graph paper be in either one. This is the confusion, okay? Negative 2.5, well, if that's how far you come out from the radius, what's the negative mean? It actually means you back up in the opposite direction. Okay? So if I went back to this point I did a minute ago, and I changed this to a negative 3, it would say, go to pi over 4, but then instead of going this way 3, back up 3 on the opposite ray, 1, 2, 3. It would be right here. Okay? If I said Q was negative 3 pi over 4, it would be back there. So, on this question, they double whammied us. They said go backwards 120 degrees, and then don't go out 2.5, but go back 2.5. Okay, so it wound up over here in what we would have normally considered the first quadrant. There aren't really quadrants because there's circles, right? All right, so you could also do these without graph paper. You would just basically draw a 45-degree angle and say, I went out exactly 2 units, okay? And that's where you would end, and you wouldn't need that extra. This one would be 2 pi over 3, which would be around over here. But you would do what? You would extend it this way and go back 1.5 units this way. So you would have 1.5, and this was 2 pi over 3, so this is actually negative pi over 3 this way. We'll talk more about those. All right, 3 negative 30, so you went this way and out 3. So real fast, help me do these without graph paper. I don't know that you have these, do you? So pi over 2 means I rotate around to here. Negative 1, I'm pretty sure you've never seen this, so brand new stuff. Back up 1, instead of going out 1, back up 1, so it would be on that first circle, if we had a circle there, of radius 1. So it's 1 unit from the pole on the opposite ray of pi over 2, so it's actually on. Now, do you remember I said we're going to have multiple names? Another name for this would be this. Does that make sense? 3 pi over 2, out 1. Okay? Another name for that is negative pi over 2, out 1. What do you think? You went this way instead and straight out 1. Anybody want to try the negative negative? If you backed up 3 pi over 2, so you went all the way around to here, and then backed up 1. Crazy. Okay, that's a pretty easy one to understand. That's why I did that one. But 4 names between 1 rotation, either way. There's actually infinite names because you could add on 2 pi's and stuff. Okay, or 360s. So this one, where would you wind up? 240, yes, and out 1, 2.5. Negative 5 pi over 6 would be almost to negative pi, right? And out 4, so this radius would be 4. All right, let's try some that you have. Do you have these two? All right. Well, let's do these two since they look so pretty. Negative 7 pi over 6. Okay, some of you struggle with that kind of stuff. Here's 7 pi over 6, right? So instead of going this way, that same amount, which was 1 past pi, right? You're going this way. So we're here, yes? This is negative 7 pi over 6 is this line. This means I go from the origin 1 radius and a half a radius would be right there. Everybody okay? Okay, who thinks they can explain that nasty mess? Here's 135 positive, right? Which would be here. It's actually 225, but it's negative 135 for our business today. Okay. So negative 135 was this way, but the negative on the radius is instead of going out to 1, 2, I have to back up in the opposite direction 1, 2. And that's us. All right. So you have this one. Can you do this one? Did you already do it? 60 degrees, out 3. You want to know what my issue with these? I never want to count this first circle. I don't know why. I want to count this as 0, and it's not. 0 is here. This is 1 unit away. It's just that they don't try to extend those lines all the way because it'd be a mess, right? So this is 1 unit, 2 units, 3 units. They are pretty good about labeling them over here. Easy for me to say, right? Sometimes they'll count by 2s, so watch it. They would have it labeled here if they were counting by 2s. Oh, we should label it R. And I put them on the quiz. You just have to label them with. Okay, negative 4 pi over 3. Okay, 4 pi over 3 is here, but I'm going that much negative, so I wind up on which line? Negative 4 pi over 3 winds up on the 2 pi over 3 line. And out 4, 1, 2, 3, 4 would be here. And that is Q. How we doing? Negative 150. Did I give you a degree graph paper this time? So 150 is to here. Negative 150 would be the 210 line. But this negative 2.5 means that we don't go out towards the 210. We actually back up to what? The 30 line, yes, is the other side of that. And we go 2.5. So 1, 2.5 would be halfway between circle 2 and 3 there. It's back to plotting points, right? All right, multiple names for the same point. We are so smart. We already talked about that. So I'm going to skip here. Here's an easy one. Here's T. It is 4 units out on the 135. Anybody give me another name? $315 would go around to here, yes? And then back up 4. What do you think? Does that work? That's what Ariana said. Go around to 315, but then back up 4. That works. Anybody help me with some more names? Negative 225, I heard Reagan say. So you went this way, and when you land here, then you just go out 4, right? You don't need to back up. Negative 45, negative 4, Michael says. Does that work? 45 negative would be this 315 line, right? And out 4 backwards. You're adding and subtracting 180s, but you really have to, I can't just tell you the rules off the top of my head. I just have to think about what makes sense for where we are on the graph. All right, so you have these. Okay, so 3 additional names. Okay, basically changing all the signs around. So this one, 5240, would be here, yes, guys? And out 5 units. Okay, so that's at 240 degrees around this way. So some things would be the opposite end of it would be 180 less, which would be what line? 60, yes. Negative would be how much? Negative 120. Okay, I think that's what we need. Now let's think about writing these. Okay, so I could go positive 240 and out 5, or I could go negative what? Negative 120 and out 5. Or I could go 60 only and then back up 5. Would that put me over here? Or if I went negative, I'd have to go negative all the way around to here, which is negative 300. Because this would be 60, so this is 300. And if I did that all the way around to there, I'd still need to back up 5. So, on the question I put on the quiz, this is probably easier in degrees, yes? Okay. I'm not actually sure I put it on the quiz in degrees, but I may have made it a multiple choice question. Like, here's 4 answers, which one doesn't work? Okay? So at least there's choices. Pi over 6 is here, yes? And it's out 2 units. Okay, who's really lost on this? Nobody? Okay. Well, what if I went the negative way around? Starting here, sorry. This was pi over 6 this way. Wouldn't you just like subtract 2 pi? Yes? If we subtract 2 pi, we'd be at 11 pi over 6, and we'd be going negative, yes? And then still out 2. All right. That takes care of the 2 positive ones. What if I want to wind up over here on this side of it? Okay, that's 7 pi over 6, and then you'd have to back up to, do you see where Hofbauer thinks this should be a other order? I have trouble writing it in the right order. All right, or this 7 pi over 6 line is how far backwards? Negative 5 pi over 6. Again, if you took 7 pi over 6 and subtracted 2 pi, get the negative pi over 6, okay? All right. Polar equation graphing, there's a whole bunch of fun to be had with this eventually, okay? We're going to do 2 super easy kinds today, lines and circles. Because circles are the easiest thing ever, okay? Look at this circle. The polar equation for it is r equals 2, because it's all points with a radius of 2. Circles we can handle, yes? It's just r equals and whatever you want the radius to be. That's going to make a circle on polar graphing. All right, lines we can't do on our calculator actually, but it's going to be theta equals, and then you could give it multiple names, but you need to tell me one of the angles. So every point, every radius where I have rotated pi over 6 would give me this line right here. I could also call that theta equals 7 pi over 6, theta equals negative 5 pi over 6, whatever, okay? So how would you sketch this? Yeah, or even on any kind of graph paper, you'd go out to 3 and make a circle, yes? Doesn't matter which way you go out the 3, up, down, left, right, because it's a circle. And this one, 2 pi over 3 is here, yes? And it's a theta equals, so it doesn't matter what the radius is. It's going to be all the points no matter whether you went out 1, 2, 3, 4, 5, negative 1.8, negative 0.17, anything on that line. R equals 3, negative 60. Oh, here's the ones you have. Okay, what's the first one? Radius of 4. I'll amuse you by attempting. That's not my worst one. Okay. What's this one? 3 pi over 4. Oh, that's not on here. Where's 3 pi over 4? This is 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay. And it's a line, right? Negative 300 is around to 60. And is this a line or a circle? Just kidding. There was a little distortion. Is that what you like? It looks like the line bend, refraction underwater, where you looks like something bends underwater. Yeah, it's my bifocal. We'll go with that. All right, last concept. The last concept is finding the distance between 2 points. Okay, this problem is kind of complicated. Do I have another example on here of this today? Okay. This problem could be easier because of the way they've written these points, but negative 460 would be go around 60 and back up 4. 1, 2, 3, 4. So what's another name for that, guys? Positive 4 and 240. Okay. The other point is at 105, which isn't on our graph paper, but that's okay. 105 around this way. And it's out 1 radius right there. We want to find the distance between those. Can't use distance formula anymore because we don't have xy coordinates to begin with. Any ideas? This side is 1 right here. This side is 4, yes? The angle in between those is 135, right? Now, we did have to switch this around a little bit for that to make sense, but the angle in between them is 135 degrees. Okay, let me redraw much larger. 4, 1, 135 degrees. What I really want to know is how far is it from here to here? What did we talk about yesterday? Okay, how did it go? X squared equals 1 squared minus 2 times 1 times 4 times cosine of 135. Type, type, type. Okay, I got 22.7, but what didn't I do yet? I got 4.8, or 4.75. What was this? 7.6. Yeah, that's better. Distance in feet. Okay, that's supposed to say feet. There is a formula you can use. There is a formula you can use. It's here. Does this not look like what we just did? Okay. It's exactly what we did. It even would have worked with the negative 60 or the 60, as long as you put the negative 4 in. Guys, the formula is on the reference sheet, okay? It's on that yellow reference half sheet I gave you, okay? So please be working on worksheet 5. The problems are on the back. It's all worksheets. There's nothing out of the book. Even though it says it is, it's all on the worksheet, okay? Practice this.